March 10th, 2011. We're doing part 2 of chapter 2 and 3 review. Make these notes on page 92 in your blue notebook. You guys need to have this vocabulary. You need to know these words for your test tomorrow. So make sure that you can define, so you know by heart what the medium of a triangle is. We have a little diagram to help you. Parallelogram is, what parallel is, what a right bisector is, midpoint, diagonals, perpendicular, and negative reciprocal. I'm giving you 2 examples. Make sure you guys know what those are for our test tomorrow. First, we'll start with a question. You may encounter a question like this. We'll call this example 1. That gives us, let's put some coordinates here. Okay, so maybe you'll have a question that gives you 2 points. We'll call them A and B. Try not to write at the top. We'll say coordinate A is -2 and -5. And coordinate B is, let's say, 1 and -2. I like that. Okay, we have 2 coordinates. We're going to call this actually, point A is the beginning of the line, and B is the midpoint. The midpoint of this line. I'm going to ask you for coordinate C. Okay? So you need to be able to tell me what coordinate C is. So we're looking. B's midpoint, we don't know what C is. Find the coordinate.
So we can plug in our distance formula, right?
Is it 2 R's? No.
Yeah.
Coordinate. Okay. So, in order to solve this, who knows what we would do? Irvin. I have a midpoint. Quentin.
So you use your distance formula and you can solve.
Yep. So, step 1, solving this. Well, let's say step 1 is actually plotting the points. If I give you a graph, it'll always help to plot the points. We have a mental image.
So your x2 and your
Here's our A, and our midpoint is B at 1, -2. There's our B.
That's our midpoint.
That's our midpoint. So we have some line going like this. I just don't know where it's going to end. It could be out here. It could be down here. Trying to figure it out. I don't know. Okay? We got to find where point C is. Point C would be the end. B is our midpoint.
Okay.
Oh, that was kind of neat.
It's kind of cool.
Midpoint. Okay. So, very first step, like you said, Quentin.
Distance formula.
Step 1,
So this is
distance.
Could you also use this if you were just finding what C is? You don't have midpoint, or you're just trying to find out what midpoint is? You do the same step. So get A.
So, right now we have line AC, and B is the midpoint. I have the coordinate of A, and I have the midpoint. I don't know what C is. So I want you guys to find the coordinate of C. C is the end of the line. Okay? So there's a couple ways we can do this. Step 1, like we said, we can use our distance formula and find the distance from A to the midpoint. So from point A to midpoint B, we find our distance. And if I'm asking for the distance from A to C, once I have that distance, what would I do?
Double it.
Just double it. Once I have this distance, to find the distance from A to C, because B is the midpoint, B is our midpoint, we just have to multiply that distance by 2, and we have it. Okay? But finding that point's a bit difficult. We have a distance, that's great, but I'm in a ruler, I'm on an angle here. So luckily, we do have a graph. One way to look at it is we can go to our right angle triangles again. So on this question, I'll probably be asking you what the actual distance is, and I want you to give me the coordinate. So we'll take a look. From A to B. Okay? How far is it from A to B? 1, 2, 3. Looks like that when we're going across the x-axis. And from A to B on the y-axis, how far is it? 3. Pretty straightforward. That's easy. We go 1, 2, 3. 1, 2, 3. And our point should actually be here at 4 and 2. No, but I want you to verify this for me. Okay? That's nice that you can show it on the graph. This is a great way to check it. Okay? I want you to verify that for me. So, what I can also do, I want you guys to do, is you find the distances. So we have our point A. What was the coordinate of our A? A to C, and B is that midpoint. It's just like a little representation. -2, -5, 1, -2. -2, -5. And what was B? Does anyone remember? Say it again? 1, -2. All right. Sorry. I went up 4 instead of 3. There we go. So we're at 1. Thank goodness you guys are able to tell us. A way we can check this though, because maybe you will make mistakes drawing it, is we use our actual numbers. Okay? So we can find our distances from our x-coordinates of A and our x-coordinate of B. So we'll call this 1, x2, y1, y2. Okay? We can actually find a point with these distances. Okay? We had our midpoints. We can find the distance of the midpoint, or we can use our distance formula. Sorry, Jessica. Listen. There's two ways. We could use our midpoint formula and double our distance, or we could cut our distance formula in half. Okay? You got to think about this. So let's say we have our distance formula, because I said we were going to use that. Our distance formula was D is equal to x2 subtract x1 squared plus y2 subtract y1 squared, right? Well, that'll give us an overall distance. It'll give us the distance of a line. But if we were to actually stop this question and we just take a look at these two parts here, that and that, x2 subtract x1 gives me the distance from A to B, so I can plug those in for that. I'll get an actual number for it. And y2 subtract y1 gives me the distance from A to B with an actual number for that. So this is dealing with our x-axis. This one deals with how far along the x-axis we move, how far along the y-axis we move. Okay? So we take our coordinates of A and B, which we have above, -2, -5. So our x2 is 1. So you plug in 1, subtract -2. No, it's -2. And our y2 is -2. Subtract y1 is -5. Now we take a look at this. 1 subtract -2. Well, that's going to give us 3. So I know our distance is 3. And from here, -2 plus 5 is going to give us 3. So like we found with our triangle above, our right angle triangle, we move 3 units on the x-axis. We're moving 3 units on the x-axis. And because it's positive, we're moving to the right. And we move 3 units on the y-axis. And because it's positive, we moved up. Okay? So if that's the midpoint, how would I get to the next coordinate? Do that again. I can double it, just like Sheldon said. Multiply this by 2. Because this is only to our midpoint. So if I multiply that by 2 and that by 2, that's going to get me to where? Okay? So we know from A to C, the distance is going to be 6 on the x-axis, and luckily going to be 6 on the y. So how do I find that actual coordinate with numbers now? I need an equation. Where am I going 6 from? From what? From A. What's coordinate A? Coordinate A is -2, -5. So we take our coordinate A, -2 and -5, and I add those to it. This is +6 and +6. So my new coordinate of C is going to be -2 plus 6, -5 plus 6. Our new coordinate of C is 4 and 1. Let's go back up to see what we had before. That's wrong? Okay, hold on. Let's go verify, and then we'll take up the question. After I fixed my coordinate, was that right? 4 and 1 using our triangle? So we actually have numbers to verify this now, okay, guys? So we actually had to pick apart formulas. That's one of the hardest questions you're going to see on the test in terms of a formula that we haven't really used. You have to manipulate a formula I've given you. Yeah. There'll be a question like this on it. Yeah, you're going to have to think. Okay, gentlemen, so let's do a little recap here. The question said, I have a line AC. I know the coordinate of A. I know the midpoint B. I need coordinate C. I need you to prove it to me. So one way on the graph, we took a look really easily. We graphed A, we graphed B, and we used 2 right triangles. We know the midpoint is halfway there, so I traveled 3 to the right on the x-axis and 3 up on the y-axis, pretty much like our slope. So I just double that. I do 3 again and 3 up, and we're at our point. But that's our, consider that our check, okay? I'm going to want numbers. I want proof that this works, not just that you drew it and by your eye it looks fine, okay? So we need to prove this. So to prove this, we had our distance formula here. What's important about this distance formula is you guys have to realize what it's trying to tell us. The very first bracket, x2 subtract x1, is telling us the distance on the x-axis. How far along the x-axis we moved. So we plugged those numbers in. If you guys remember, we got to 3. That's how far we moved on the x-axis. We started at started at -2 and went to 1. So go back up to our graph. We started at -2, and we went all the way to 1. We counted with our eyes by counting our graph. That was 3 units. And we actually proved it with numbers. We only took a piece of our distance formula. So we know the distance on our x-axis we moved was 3. Because it's the midpoint, I'm going to have to double that to get to the end of the line. So I'll have to go 3 again from there. When we double our 3, so we times by 2, we move 6 units along the line. So that's right in line here. If you guys notice, we moved a total of 6 units. We took a piece of the distance formula. We did the exact same thing.
Mr. Perino, please go to 302.
With the y-axis. Our y2 subtract y1 is telling us how far up and down the graph we're moving on our y-axis. Let's finish this part. So we found the distance of the y-axis. We moved 3 units. We double it. We move 6 units up. Exact same as our x. If you had actually carried out the full formula, you would have found the actual distance from point A to point B, which is nice, but it becomes very hard to draw on a graph. Let's quickly see what it would have been. It would have been the root of 9, which is 3. Okay? That one worked out nice. So we would have moved 3, and then we would have had to move 3 again. It could be hard to draw. You know, I could actually be at maybe 4.2 or 1.3. That's why I need exact numbers. I need proof mathematically that that is the exact coordinate, okay? Drawing 3 on an angle can be tough. It's very easy to do right to left, up and down, but once we get it on an angle, it's very hard to tell how far 3 units is.